x86 microarchitecture levels. You may have seen my videos on them in the past, or just distros generally talking about changing the baseline. As an example, an experiment on Ubuntu 2304, raising the baseline to x86 64 v3. Fedora had an idea as well. This was a bit of a different approach though, where they weren't going to raise the baseline, but offer you binaries for your specific version. So if you had a V2 CPU, you would get V2 binaries. V3 binaries, V4, so on and so forth. V4 is the newest tier right now, but eventually there would be a V5, V6, so on and so forth. Obviously, at some point, they'd also cut out those earlier levels as well. Arch Linux has discussed the idea plenty of times, but they haven't really put anything into place. But CachyOS based on Arch Linux has done so, and Gentoo now offers pre-compiled binaries at v3. But being Gentoo, you could have always just gone from source yourself and compiled at whatever level you wanted. Now, with how often the idea of raising the baseline is discussed, you might think that this is like a well-defined set of criteria. This is what is V2. This is what is V3. This is what is V4. It is this generation onwards, and everything is just like clear and understandable. And kinda technically for V1 and V2. After that point, though, things get very, very wonky, especially so in V4. Now, the basic idea is sound. If you have an x86 64 CPU, so a 64-bit x86 CPU, also known as AMD 64, we're not going to get into that today, which is what most of you are running unless you happen to be using an ARM system. I know there are some Asahi Linux enjoyers watching this channel, but if you have an Intel or an AMD system, you're on x86 64. And if you buy a CPU from, let's say, 2005, and then compare the feature set of that CPU with something you bought from 2024, the feature set is not going to be the same. Over the years, additional features have been added, and those features can generally be grouped into categories. These categories are the different version numbers: V1, V2, V3, and V4. And as you get higher and higher up in the version numbers, these add additional optimizations, add new functionality that makes things faster, and just generally are an improvement on performance over just the fact that you're using a faster CPU. Now, this is a convenient build option because it would be really annoying to have to list out every single feature you wanted when you're compiling an application. It would make things way, way more complex than they need to be. So there was going to be some sort of grouping that had to be made anyway. And whilst both AMD and Intel, alongside Red Hat and SUSE, were involved in the formalization of these levels, initially starting as a project from Florian Weimer outside of glibc, the issue is the standard isn't an old standard, it was retrofitted after being created in 2020. So when we're dealing with the old CPUs that are no longer being made, your V1 CPUs, and for the most part, your V2 CPUs, it's pretty easy to say, okay, looking back at history, these are the CPUs that fit in that category. Problem is for the stuff that's still in production. So for the most part, everything post Intel Haswell, AMD Excavator, and Intel Atom Gracemont is in x86 64 v3. Now, the problem is how new the chips are that are still in v2. The predecessor to Gracemont, that being Tremont from 2020, does not have AVX. Because it doesn't have AVX, that puts it into V2. So you have a 4-year-old chip, which is going to be in devices that people are still running today, that is in V2. So if you say, well, Haswell's really old and Excavator's really old, let's set the baseline to V3, it cuts out all of those devices. But don't worry, things have only just gotten started. With newer CPUs, you have a different problem. Basically, hybrid CPU support levels, because now we have this thing called big and little cores. If you ask Intel, they are your P and E cores, your performance and efficiency cores. And a lot of these, most of these, don't have the same feature set on the P and the E cores, on the big and the little cores. So there are cases where you have the big cores which have AVX2 and the rest of the features that you need to be in V3, but the little cores don't. So you have a V3, V2 CPU. And then under V4, you have cases of the big cores having AVX512, but the little cores not. So now you have a V4, V3 CPU. And that's without even touching the mess that is AVX512 support, because there are different ranges of AVX512 support. Just because it supports AVX512 doesn't mean it supports the entire instruction set of AVX512. So charts like this exist. The whole V4 grouping was basically made off of a single generation of CPUs. They didn't actually know yet what was going to be in V4, and now that we've had a couple of generations, a couple of years, honestly, V4 needs to be completely rethought from the ground up, because it is a complete mess. So what once could have been a convenient build option when working with glibc has become this, well, not even become this, started as and became worse, this mess of questionable support on different CPUs, and CPUs far newer than they should be, not being in certain area. It's just not a good idea, basically. Now, the reason why we're talking about this is because of a discussion that happened in the kernel, a patch that's sent up by Arnd Bergman. While looking at 32-bit ARM cleanups, I came across some related topics on x86 and ended up making a series for those as well. Primarily, this is about running 32-bit kernels on 64-bit hardware, which usually works, but should probably be discouraged more clearly by only providing support for features that are used on real 32-bit hardware. Now, the patch we really care about is patch number 9, rework config generic CPU compiler flags. Building the x86 kernel with the config generic CPU is documented to run on all CPUs, but the makefile does not actually pass an march argument, instead relying on the default that was used to configure the toolchain. This is going to depend on the specific distro, or in some cases, the user if they actually configure the toolchain like you would on something like a Gentoo. In many cases, GCC will be configured to march x86-64 or march K8 for maximum compatibility, but in other cases, a distribution default may be either raised to a more recent ISA or set to march native to build for the CPU used for compilation. So if you don't care about supporting other systems, you only care about compiling for your specific system, that's a perfectly fine option. This still works in the case of building a custom kernel for the local machine. The point where it breaks down is building a kernel for another machine that is older than the default target. So let's say you have a V4 machine and you have it set to native and you want to compile that kernel for another machine that is V3 or V2. That is going to use features that are too new and will not work. Changing the default to march x86-64 would make it work more reliable, but possibly produce worse code on distros that intentionally default to a newer ISA. To allow reliably building a kernel for either the oldest x86-64 CPUs or a more recent level, add 3 separate options for V1, V2, and V3 of the architecture as defined by GCC and Clang, and make them all turn on config generic CPU. Based on this, it should be possible to change runtime feature detection into build time detection for things like CMP XCHG 16B, or possibly gate features that are only available on older architectures. Now, this got a response from Mr. Linux himself, Mr. Linus, Linus Torvalds. On second thought, let's not go to x86-64 microarchitectural levels, 'tis a silly place. The whole V2, V3, V4, etc. naming seems to be some crazy glibc artifact and is stupid and needs to die. It has no relevance to anything. Please do not introduce that mind fart into the kernel sources. I have no idea who came up with the microarchitectural levels garbage, but as far as I can tell, it's entirely unofficial and it's a completely broken model. Now, sadly, it's definitely not unofficial. As I said, both AMD and Intel were involved in the creation of it, but considering just how confusing of a model is, how often the model is broken, how often new CPUs that should not have been in a category were in a category, I can understand why you might think it's unofficial, because it is a completely broken model. If the people who made the levels cannot even agree what level their CPUs are, and V4's especially bad for this because they can't even agree what functionality is supposed to be in V4. If that is the system you're dealing with, it's not a good system, right? Like, Intel and AMD are going to work on different feature sets. There's going to be a lot of overlap there, but when you have this new developing level, they're not really sure specifically what's going to stay around. So it's hard to say this is what you need to be in that level. And V3 is better, but still not perfect. There is a very real model for microarchitectural features, and it's the CPU ID bits. Trying to linearize those bits is technically wrong, since these things simply aren't some kind of linear progression. And worse, it's a simplification that literally adds complexity. Now, instead of asking, does the CPU support the CMP x CHGB16 instruction, the question instead becomes, of what the hell does V3 mean again? So no, we are not introducing that idiocy in the kernel. Linus. Now, I understand what he's saying here. Whilst theoretically a grouping would make things easier, the groupings are not at all clear for what is actually contained within that group. Let's not even talk about V4, where even the developers of the groups can't decide what is supposed to be in the group, let alone people trying to use the group to say, this is the feature set I want. So unless you memorize the entire list of instructions, which I'm sure somebody has done, but there's a lot of instructions, and you're probably just going to go look up an index unless it's some major feature you use very frequently, it doesn't actually simplify the process. And the developer was pretty receptive to this. Fair enough, I'll just make it use march x86-64 to override the compiler default then, so they know exactly what it is going to be using, and is not going to be using whatever the distro defines by default. If the distro wants to go and define something themselves, they can go and do that, but at least by default in the kernel source that is actually shipped, in the kernel source you can grab, it's gonna go and compile it just for generic x86-64. I agree that both the name and the concept are broken. My idea was based on how distros, Red Hat Enterprise Linux at least, already use the same levels, making user space require newer CPUs, so using the same flag for the kernel makes some sense. Making a point about the levels being stupid is a useful goal as well. Now, the reason why Red Hat uses it is, well, Red Hat was involved in the formalization of the specification. The glibc guy who actually, started the idea was from Red Hat. Now, there is one part that Linus was kind of receptive to. I do think the one option we might have is optimize for the current CPU for people who just want to build their own kernel for their own machine. That's a nice, easy choice to give people, and -march equals native is kind of simple to use. Will that work when you cross-compile? No. Do we care? Also no. It's basically a simple, you want to optimize for your own local machine switch. Maybe that can replace some of the 32-bit choices too. This idea of CPU microarchitecture levels is a neat concept, but look, it frankly needs some work, and Linus is not the first person to point out that there are problems here, and he's not going to be the last. But I don't really expect anything to change. I expect them to stick around. Maybe there'll be some rework of V4 so it's actually applicable to real CPUs, but that's about as far as I think it'll go. But let me know your thoughts down below. Do you think anything's going to change? Do you think the idea of CPU microarchitecture levels are actually a good thing? I'd love to know. So if you liked the video, go like the video. And if you really like the video and you want to become one over these amazing people over here, check out the Patreon, Scribes, Liberapay, linked in the description. down below. That's going to be it for me, and what CPU do you have?
Something like this.